Hello. So today we're going to work on the first problem of Leetcode to sum, and this is the journey that we're trying to complete the 150 Leetcode problems. Um, so we're working on this now, and for those that just start working on this and then encounter the two sum problem, don't be discouraged if it takes you a while to try to solve it, because it's also took me a while too. I did solve it initially using brute force, so it's O of n square time complexity, but I was trying to reduce it down, and it takes me a while, so don't be discouraged. I already solved it once when I figured it out, and now I just do this video. It looks quick because I've done it once, so don't be discouraged. Um, so with two sum problem, the first thing that we're gonna do right now is we're gonna use brute force approach. The way that we're gonna use brute force approach is we'll just gonna loop through each of the element twice, and then we're just going to compare each of the element with each other and then sum it and see if it's the same as the target. If it's the same as the target, we're going to compare the position I and position j to see if it's the same or not. If it's not the same, then we'll return the position I and j. So all right, so initially, like I said, we'll loop through each element. So for now, let's just loop for I in range, length, nums, and then so this is now we loop through one. So we'll loop through like 2, 7, 11, 15, and now we're gonna loop through um for j in range, length, nums. So now we'll loop through the exactly the same thing, see if it's the same. But the good thing is we don't actually have to loop through I and j like that. We could just do um like rather than start it at the same position, we could start at the plus one, but for simplicity's sake, because this is still O of n square, we're just gonna do it this way. And then now we're gonna check if num I plus nums j is the same as the target, because if it's the same, then we're gonna check if I is the same or different from j. If it is different, that means it's correct with the assumption that like it cannot be in the same position, so we could return that. So we could just return I and j that way. Other than that, we'll return an empty list like this. So run it, it passed. Let me submit it to see if it works. It works, but it's really not efficient memory wise. It is, but it's not with the runtime complexity. So we're gonna try to make it better. And the way that we could make it better is we're gonna use hash map to help us out. So I believe the first example that was given to us was 2, 7, 11, 15 in an array. And then the target is 9. So target number is 9. So since we gonna use hash map, let's just set hash map up in the beginning. And a hash map is actually gonna store the element in this list and then its position. So we're using Python. The hash map would be in form of dictionary. Sorry. And so what we're gonna do is we're still gonna do the for loop. So we're gonna check each of the element over here. Um, I'm not gonna do pseudocode here, but we're just gonna work on it together. So first we're gonna have 2, and then I'm just gonna write each of the element this way. So 2, 7, 11, 15. And when we first loop through it, it's gonna be number 2, and then we're gonna get the complement number. The complement number would be equal to the target minus the number in the element. So in this case, it would be 9 minus 2, so it will be 7. So our complement number right now is 7. And we're going to check if 7 is we're going to check if 7 is in the hash map. If it's not in the hash map, then we're going to store these number over here onto the hash map. The number will be so right now we're going to store the number which is the element and number. So index 0, the number is 2. So we store number 2 here, and then the value of our hash map would be the positions of number 2, which in this case would be 0. And then we get onto the second number in the loop, so it's going to be 7. So now we get the complement of 9 minus 7 would be 2. We do the same thing. We check if um, it's in the hash map, which in this case it is in the hash map. So now what we're gonna do is we're gonna return the um the positions of number 2 in the hash map, which is 0 because it's the value. So we return 0, and then the I indexed of number 7, in this case is 1. So here we could see um to get the number 9, the 0 and the first index would be how we're gonna get to it. Let's actually get on to the second example so that we're clear on it. So 3, 2, 4 in the array. Oops, not here. I'm just gonna do 3, 2, 4 here in the array, and then the target is number 9. So the target is number 9. 9 is a target here. So we'll do exactly the same thing. We'll get the complement number. So 9 minus 3 here is 6. So we'll check if 6 is in a hash map, which it is not in a hash map, so we add it in. So now the number is 3 and the index is 0. So now we get our first in a hash map, and then we'll get the complement number of the first index right now. So 2, the complement number would be 9 minus 2 would be um, 7. So we're gonna check if 7 is in the hash map, which in this case 7 is not. So we're gonna add 2 into our hash map. So now we get 3, 0, and then 2, 1. So these are all the element we have, and then the same thing for number 4. The 9 minus 4 is 5. So we'll check it. It's not, so we'll add it to hash map. And so in the end, there is no like um, return because there is nothing in here that get added up to 9. So in this case, we'll just return an empty string here. So cool. So now that we have a better understanding of this, let's just code it up. Awesome. So like I was explaining before, first we just gonna um initializing an empty hash map, which is dictionary in Python, and then we're gonna loop through each of the element in the array. So for I in range blank nums, and then we're gonna check if the not check, we're gonna get the complement number first. So the complement would be the number, the target, oh, minus the number at position I. So we get our complement, and then we're gonna check if the complement number is in the hash map. Because if it's in the hash map, we're going to return the hash map at that complement. Um, oops, and then the position I. But if it's not in the hash map, then we'll add the number so to the hash map. So we get hash map dot well, actually it doesn't have to do dot set default. It's trying to do dot set default. We could do dot set default. Um, the number at position I with the index I, and then we could return like empty list at the end, because if by the end there is nothing in that for loop, then obviously there is nothing. So I just ran the test case, it passed all three, so we'll submit it. Awesome. So our code is great, works fine. The time complexity in this code would be open because we only loop through the array once, but um, the memory is a little higher because we have to store each of the element and its position in the hash map. So that's all for today. Thank you for watching and hope you have a great day. Thank you.